So the aim of this exercise is to take a data set and use R Markdown and ProjectTemplate to load the data, do some preliminary scoring, an initial reliability analysis, and then run some basic correlation and plot type analyses. So the data set is called the BFI data set. It has data on 25 personality test items, and they correspond to measures of the big 5 personality. So 5 items for each: agreeableness, conscientiousness, openness, and so on. And we've also got some demographics, gender, education, and age. So I guess if we're going to analyse this, we have to look at the raw data, see if there's any issues, score the tests, check reliability, maybe run some correlations and look at group differences on the demographics. So are males or females different in personality, or does education relate to personality, and so on. Okay, so the workflow that I'm going to show you is the ProjectTemplate workflow. And I think this is really great for organising an R project. It resolves a whole bunch of little issues that you'll encounter if you do alternative approaches. We're going to use the ProjectTemplate approach. There is a general website that describes ProjectTemplate. So it's a way of organising all your code and data. It's a standardised way of importing data and so on. But I'll use my modified version, and I guess the more you use this approach, you come up with this little set of folders and files that's adapted from this. But anyway, I find it's a bit nicer. So that's, yeah, it's online somewhere. So it can be downloaded from here. If you want, you can download it direct from there, or I've got a copy of it in here. Okay, so if we unzip that, we get a project. Yeah, so I've unzipped this zip file, and what's inside is a bunch of folders for data, for data manipulation, and so on. The first step is to give it a name, so I'll call it R exercise. And you also have this project file which will open things into RStudio, so I'll just call that R exercise 2. Now, I can open that in RStudio if I want, so I double click on that project file and it will open up in RStudio. The benefit of doing that approach is it makes sure that your working directory is the same folder as where that file is. Otherwise, you can get issues of where is the working directory. Yeah, and we'll be working with this R Markdown file that's already there in the reports directory. You can add more R Markdown files by going to New File. Okay. So if we go back to the exercise, the first step is to import the data. Seems simple. So we have the participant data, the participant responses to the personality items in this CSV file. It's a comma-separated value file. It's just a common plain text format. And we also have some metadata. So we could have a probably quick look at that. So we have this meta file that includes all the information about the test, every item. I love children. I know how to comfort others. And whether it's agreeableness, and whether it's reverse or not coded, it's just... basically, I would say, not to cut you off, but watch and then we'll do it. I reckon that's probably the best way. And then, yeah, I think, yeah, it's too hard to kind of... I'll go faster than you can go. I think. Yeah, is that right? Or yeah, sorry. So you have the scales, and then you also have this scoring information, which I'll go through in a bit. But anyway, this will help us to score the tests later on. You also have this CSV data, which you could probably open in Excel, I think. So it's just the first row is the variable name, and then this is each of the participants' responses. So to import that using ProjectTemplate, what you do is you just copy them into the data folder. So now they're ready to be imported. And to import them, you run this one command in RStudio. So if I run that, it does a bunch of things. It loads any relevant packages, imports any functions that you've got in special folders. But in addition, it automatically looks at, oh, that's a CSV file, that's an Excel file, and it knows how to import it. And we can see up here in the environment that we've got the two data files, R cases and the metadata. So we can look at the first few rows of that and see that, yes, we have the R cases data file in here, and we could look at the first few cases of that. And yes, we've got that metadata on the items. Yeah?
How far do you have to go when you're checking out the data being imported? You just need to do the head.
Yeah, I usually do head.
And that's it?
Well, you could do dim. So that tells me the dimensions.
Yeah.
So I can see that there's 2,800 rows, and presumably I already know roughly how many cases there should be.
But you would just need to run one command to just check that it's...
Yeah, I pretty much would always run head and dim just to check it's right. Or you can do str, which is the structure. So it tells you each variable and gives you a few things. You can get descriptive stats. Although that only works on AM. But yeah. So the important thing is we've imported our data. You know, and that's can be a real struggle in just getting the data into R, because there's all these different commands for different file types and different options and so on. So generally, not always, but ProjectTemplate will do the right thing for most files. And the name of the data frame will be drawn from the file name. So this was called rcases.csv. It's imported as rcases. Yeah. Okay, so the next thing, so a data analysis workflow involves importing data, transforming data, analyzing data. In those steps. Because if you do import, analyze, and then transform, well, the data is not transformed the way you want it for your analysis. Okay, so a standard step is to do some data manipulation. And that could be adding value labels, or it could be transforming data. You know, if it's not normally distributed, you might transform it, or you might delete a few rows from your data file because they're bad participants who didn't answer enough questions, and so on. So RStudio standardizes that process by having a designated folder where you store all code that transforms your data. And that's got the slightly interesting name of munge, which means to manipulate data. And the idea is you put all these data transformations in this file so that when you restart the project, these commands get run automatically. So when you run this library ProjectTemplate load project, it will import the data, then run all the data transformations, and so that you're then ready to go to analyze your data. Instead of kind of the SPSS workflow of, well, I'll import my data, I'll do a whole pile of things and then save it, and then I'll have this new data file, and I can't quite remember how this variable was created, but it was created at some point, and then et cetera, et cetera. This sort of keeps it in one reproducible workflow, which is attractive, that you can check it and so on. So yeah, we're at this stage now. The task was we wanted to, I guess, give value labels to gender and I think it was to educational status. So we've got our cases gender and it's 1s and 2s. So that's, we've got to work out, well, how do we score this thing? And so if we look at the metadata, it will presumably tell us how to score it. So I'll just copy that. Just make that a comment as a reference. Oops. Sorry, I'm trying to show you how to do it in menus, but yeah, okay. So I've just commented that out, that's a reference. Okay, so we want to create a new variable that instead of having 1s and 2s has male and female. So for that we have what's called the factor function. That's a way of getting help on that function. And essentially factors are a little bit like variables with value labels in SPSS. So they would take, it takes as its argument the original variable, the values that it takes, and the labels we want to have. And it returns a new variable with the labels. So I'll call that, to assign that into the data frame, I'll just call it like gender F or something. So this is assigning it to the data frame R cases to a new variable called gender F. Yeah. And we could just check that that worked. And sure enough, that's a cross tabulation. 1s have become males. And we could repeat that process for this one. So, oops. So I guess that would be like, and so on. So this C thing is just for the elements of a vector. So yeah, so that was education. So hopefully we can check that it worked. This is also quite useful to, with the dollar thing, you can sort of, you get autocomplete, so you can sort of tab complete it, which is quite good. But yeah, so it's recoded that. So yeah, that's just a simple step, but yeah, we've created some value labels. You know, instead of numbers, we've got text. Okay, so another step we might want to do is just check whether the personality test it's got valid values. There's no values outside the range. It's all looking good. It's a 1 to 6 scale personality test. So we can check that everything's in range. So there's many ways that we could do that. So we could go, okay, well, the first question, does it look like it's all in range? Hard to say. There's a range function. This is a little surprise. If you have missing data, often you'll get nothing. So if we go, a lot of these functions like mean and stuff have this remove the missing data. Yeah, we see that the range is 1 to 6. The psych function also has a nice thing that will give you all sorts of descriptive stats, including the min and the max. And that can also be extended to many functions, many variables. So there's a few. A really cool tip for R in terms of selecting variables, I'll just show this. So I think I use this all the time. It's very powerful for doing analyses. Is you can get all the names. You get the names of a data frame like this. So that's all the variable names. But if you put it in this thing called dput, it'll give it in a form that's easy to kind of copy and paste. So I could copy and paste all these variables, that's all the personality test items, using dput, like that. So now I've got all the items and it looks pretty good. If you find you're frequently reusing sets of variables in multiple analyses, you may not want to have to manually kind of select all these variables. And so another really powerful tip is to create what I call sets of variables that you give a name to, and then you just refer to that set by name. So these are like the items, or the big 5 items. So what I often do is I'll create a little list, and I'll give it, I just call it V by convention, but you can call it whatever you want. But I create this list, which will be a list of variable names, which I frequently reuse. So if I've got the items, it becomes one element in the list. And as I get more variables, I'll use it like that. So every time I want to access the items and do something on them, I can do that. Oops. So that's all the items. So every time you want to refer to them, so not that we're doing factor analysis today, but if I wanted to do then a factor analysis, I could just go the items and 5 factors. There's missing data. And I could get a factor analysis on those items. We could go into that, but the point is that it's quite nice to set up these variable sets so you don't have to type out lots of variables all at once. Anyway, the initial goal was just to check, are they all on a 1 to 6 scale, and is that all fine? And they look all good. 1 to 6. Okay, so the other thing we might want to do is just check, what's the status of missing data in this data set? How much missing data is there? Which variables have more missing data? So let's have a look at that. So there's a function called is.na, which tells you whether something is missing. So that looked at every variable there and tells me which ones are missing. Another nice property is if you take the sum of a true-false variable, it tells you the number that are true. So that tells me the number of cases with missing data for that variable. Now we might want to do this for the whole, I don't know, for either every variable or every case to know which variables are missing more or less, or if there are particular cases which are missing a lot of data. This is next thing's a bit more advanced, but I think it's a really powerful tool. If you want to apply a function to every column, you use this thing called sapply. So it will apply the following function to every single column. So if it looks a bit like this. X is the column of data, and we could go sum is.nax. So what it's doing is for every column, it's telling you how many cases are missing for that variable. And so it's saying A1 has 16 missing, you've got much more missing on education, and also it's the education factor, that's the same variable that we created before. So yeah, it's a way of applying a function across a set of variables. So just to give one other illustration, we could use and get the, I don't know, so that would give us the mean of each item, for example. Anyway. Okay, so that's giving us, tells us which variables are missing data. It seems like it's a bit of a cross-section of the items. We can also see which cases are missing more data, and for that we use what's called the apply function. It's very similar, but the second item argument tells you whether you want to do it by rows or by columns. So 1 is for rows, 2 is for columns. So if you want to do a function across rows, the second argument is 1. So if we then use this same function, it tells us how many observations people are missing. So yeah, I might be getting ahead of myself, but the next exercise was to say, well, let's see how much data each person is missing, and let's throw out the people who are missing most of their data. So we can actually add this, like it's a new variable, like nmiss. Oops. So I've added a missing count to each person, and I can get a table of that. And this tells me that 2,236 people are missing no data, a few people are missing 1 or 2 items, and then you've got this much smaller number who are missing a lot more. And this is actually quite typical of psychological studies. You may want to throw out the people, it's going to be a big hassle. These people are missing, lots of data. They're going to cause problems with analysis, and they're such a tiny fraction that maybe it would be simpler just to remove them. So we could set a cutoff, like if you're missing 4 or more, you're out of the study. So I could call this retain. So we'll retain anyone that has 3 or fewer observations. So does that look right? We're going to drop 13 people. So this is where I would typically create a new data file. I quite like R cases for raw, and because you always start off with this raw data file and you throw out a few cases and you've got this sort of final data set. So we could filter on this. So by putting this logical vector here, it's selecting just the people where that's true. Oops. So I'll just put that in the right spot. Yeah, so now instead of having 2800 rows, we've now got 2787. Yeah, so we've cleaned the data file a little bit. Another common challenge for psychology is scoring tests. We're always scoring tests. Multi-item surveys, some positive, some negatively worded items. It's always a big pain to work out which items go with which tests and put it in manually. R has a really powerful function. You just got to know what the inputs are, but otherwise it works very nicely. So this function is called score.items. It's in the psych package, so you have to make sure that that the psych package is loaded. But I've already got that set up one of the other things that RStudio does is auto-load the packages you've got listed here. So if there's common packages you use, and psych would probably be one in psychology, then you sort of just add it there. So yeah, to score items, you need to have a key that tells you how to score the test, and then you need the data frame. So that's where this meta.bfi comes in handy. So in this is already set up nicely. So what you need is the variable name that tells you whether the word item is negatively or positively worded, or whether it's unrelated to the test. And also, basically we want to pull out these 5 columns for the 5 variables we want to score, and this tells you whether the item is included. If it's not included, it's a 0 in that column. If it's a positively worded item, it'd be a 1, and if it's negatively worded, it'd be a -1. So, for example, this first item is a -1 for agreeableness, and then different to the feeling of others. So clearly it's a negative agreeableness item. Yeah, so I'll just get the names out, because we'll need them. So specifically we want these 5 variables. So these are the names of the tests. So I'll have to refer to this a few times, so I'll just put them up the top here. Call it Big 5. So I've added that to the list, so now I can use it. And so I could go Big 5, and that will be just the kind of scoring key. And that's what score.items needs, essentially. Then we need the item information sorted in the same order as the key. So we have those variables are listed in here. I think that's it. Yeah, so they're the variable names. So they're corresponded to the names in the actual test. You just got to make sure it's in the same order, so it's useful to put it in there. Okay, so there's many other options. You can decide whether you want to. I'll just do the. There's many other options in this function. You can get sums and means and how it deals with reversals and so on, but this is the basic thing, I think. So if I run that, it will, in theory, score the tests and give you reliabilities for all scales. There's the reliabilities for the 5 tests. If I want to add those scores to the data, you would usually assign it to an object. I just called it SC, but it could be called anything. And somewhere in here, if you do the $, you can see the elements of what's in there. So, for example, you could pull out the alphas. And sure enough, there they are. That's the reliabilities. Or you can pull out the scores, which is just a big data frame with all the scores. So I can then plonk those in there, like that. And now C Cases has, well, all those tests. So yeah, it's a little bit fiddly, I suppose, but so is any scoring system for tests. And so you could imagine, as long as you've got your metadata organised smoothly, you could score psychological tests quite quickly. Yeah, so it runs like some descriptive analyses of the test, and it calculates scale scores, which you can then merge back into your data frame for future analyses.
So what are you assigning to SC?
So many analyses will return objects. It's not the mental model we think of in SPSS. Like in SPSS, you run an analysis, you get output. But in R, you can run, say, a multiple regression, save that object, and then pull out bits like the R squared or the regression coefficients. Same thing here. You can run a test scoring procedure and pull out the alpha reliabilities, the item total correlations, or the score. So we've already done then step 9. As a byproduct of oops. Yeah. So sometimes it's nice to round it if you're getting too many decimals, but yeah, there's our alphas. So not too bad. Neurosyn's pretty good. Openness not so great. But, and I think in the SC you can get yeah, item total correlations. So you could start to tease out what's going on there. Let's look at the correlation between the big 5, for example. So here's the correlation between the big 5. It's a little bit tricky to read. If we round it to 2 decimals, you can see the correlations. You know, there is a way of getting significance tests for. Yeah, I mean, let's see how quickly I can find how to do it. It's a good example. So correlations with significance tests. So that's what came up for me. So let's see if this just magically works.
Is that library attached to the project template already?
It might be already, I'm not sure, yeah. So yeah, this looks like it's given it to us. We've got correlations and p-values. Because we've got 2,800 people, everything is significant. But yeah, so you can get it. You just got to kind of Google for it. So let's look quickly at a few distribution things. Sorry? So that was kind of skipping ahead to number 12, correlate the big 5. Let's just have a look at distributions. If you wanted to do that, you could do that describe function from the psych package. Oops. So that would give you skewness and kurtosis. You know, it's kind of telling us agreeableness has a bit of a negative skew, etc. Oops. Or we could run a histogram on this. So not a bit short on space here, but yeah, let's see if we can get it. So there are the histograms of the 5 variables. You can sort of see the ceiling effect going on in agreeableness. We could also look at group differences, say on gender. So there's different ways of doing that. You can do a t-test, predicting, say, agreeableness from gender using the C cases. And if you didn't know what those arguments were, then you could do it there. So that shows the group means on the 6-point scale. So females are slightly more agreeableness, 4.8 versus 4.4. And the CT value, degrees of freedom, very small p-value. You could repeat that process, of course, for each of the big 5. The final thing I'll show is some plotting stuff. You could plot the relationship between age and the big 5. Yeah.
The little dashes at the tilde, so what, that's the correlation, is it?
Yeah, it's sort of a bit of an R notation when you're running. There's a lot of contexts where they use this notation. The left is predicted by the right. In particular, you can do multiple regressions like this, and yeah, I could add more variables like. And so you can start building up regression models where this is predicted by this plus this plus this. And it's a general notation for fitting regression models. Yeah. And you can also include interactions in some contexts as well. But yeah. So the final thing I was going to show is just how to plot the relationship between two variables. And yeah, I wanted to show you ggplot2. This is a very attractive graphics package. And generally, most people would start with some documentation or the cheat sheet and build off that. So there's usually, if we look at, I don't know, you can often start with one of these examples and build it up, depending on your use case. So in this case, we would write ggplot the data frame, see cases, and then you have this strange term, aesthetic attribute. X is age, Y equals, say, agreeableness. And then, then you attach some type of graph. So that's the relationship between age and agreeableness. Not entirely clear, but we can add what's called a geom smooth. And that shows that young people are not getting agreeableness, and then they increase and then sort of plateau. Yeah. And so you could repeat that plot for the other big five if you wanted to. The other thing I wanted to quickly show you was one of the point of all that sort of data importation and data manipulation was that I could just shut RStudio down. So it's all shut. All the data's lost. No, I just open up RStudio. And cross the fingers it all works. If I then rerun this one command, it's importing the original data. It's also run this script. So all this script has been rerun, and I'm now good to go. So, for example, I have C cases because that initial manipulation code has been run. I'm ready to go, ready to now analyze again. So you don't actually save where the data file is at the end. What you save is your data manipulation steps, which transform your data into some sort of finished product. The other thing you can do is just knit this document to a PDF. So that will run all that code. I had a bug in there, but no, I left an error in there. Let's try again. Cross the fingers. And that has that whole analysis that's just been run. So it's all in there. At present, not in a super attractive format to share with a client, but there's lots of options that you can play with to hide various bits and so on. So if you wanted to make a fully reproducible report, you could.